Okay, so in this part, I thought it'd be interesting to maybe cover an old tutorial, an old definition by Michael Pryor that sort of builds on what we did last time, but it uses a different technique and it also uses multiple attractor points just to kind of spread out and distort the grid using multiple points, which the last file would not do, at least not so simply. So we're going to kind of walk through this one a little bit more quickly maybe, so I'm just going to grab a grid here because things are getting sort of repetitive finally. Just going to go ahead and make that similar grid to what I've been doing, you know, give it enough area to really work with, but we don't have to overthink it. Make this 36, maybe an even number this time. Alright, so we got grid 136 in terms of spacing and overall bounds. It's interesting because we'll use a different technique to draw or to separate out the rows versus the columns. And I'll use Michael's technique here, and we can kind of compare that to the one that we just covered. And it's possible to, compare the two, or actually kind of rebuild the last one with this, and it's possible to rebuild this one with the last technique of, kind of drawing lines two different directions. In this case, we're going to do it up front instead of at the end. And we'll see if that gives us any, anything new that we can talk about and work with. So I'm going to go over to sets, and first thing I'll do is kind of flip this matrix that's coming out. So I have two different options here. I got the flipped version and I got the data tree here, which is the standard option. I'm going to turn this one off because I'm going to redraw those curves. So I'll go over to curve and polyline and plug that one in there. So that'll give us our rows, our columns, and the other one will give us our rows, right? So that's just going to go ahead and draw our separate grid directions for us there. And then what I want to do is put that back together. So I'm going to go over to set and tree and merge. So this is a kind of a little lightweight introduction into merging, which we will cover probably again later. So this gives us now it's kind of an interesting way of drawing a grid, because now we have on each one of these lists, we end up with two corresponding lines, one up and one from side to side, and that those are coupled together. Okay. So what we need to do now is sort of break these down into a set of points, and I'm going to go to curve, divide. In order to do that, go ahead and plug that in there. And the number of things that I want to choose here, the n input, I want to match. You don't necessarily have to do this, but it's nice, I think, at least in my mind, to do it that way. And then we can start turning off some things, right? So what I've got now is a differently organized grid of points, and you can see that there's an extra, basically one extra, there's one extra layer of information there that we can talk a little bit about in a moment. Alright, so let's go ahead and draw 3 attractor points, and I'll just use Rhino here, so I'll just draw 3, and I like to keep them on the outside of the grid for now, and then we'll pull them in later, this way I can see them a little more clearly. So I'll go to parameter, give them that point, select multiple, and set 3 of them. Alright. And I'll just click that and internalize, so those are staying there, and then when I remember that if you're not seeing that, you just need to have the gumball turned on. Oh, actually, no, you don't. Okay, that's cool. Yeah, Grasshopper turns on the gumball automatically if it's internalized. All right, so instead of the pull component, I'll introduce another way to do this. Again, through the script that I'm following along with here. And so instead, we can use a different version of this, which is to kind of figure out what the closest point is to the 3. So I'll go to vector and the point box, and I'll find this, where is it? The closest point component here on the left, not closest points, not plural, but just closest point, because we're only going to look for one closest point to each thing. And basically the points that we're searching is going to be the attractors this time, and the data that we're basically the cloud that we're searching from will be the points that we just found from the division component. And now this is going to give us a set of distances, similar to how we worked before. And what now we want to do is set up basically a range of influence that we can set with a parameter. So let's do that. So I'm going to go to Math, and over in Operators here, I'll find the larger than, and I'm going to plug that into the A input, and then I'll use a slider for the B input. And the slider will be between, let's say, 0 and 10. And I'll give it a couple decimal points. And then go ahead and move that up already, so because we're going to need something there. So I'll just maybe get, I don't know, something like 5 or 6, something in that range, somewhere sort of in the middle. And now this is going to output a Boolean for us, either true or a false. We can use this kind of Boolean mask as a way to determine, or a way to make selections in the point grid. So some things are going to be true, some things are going to be false. So it's basically going to return the points that are true, and it's going to remove the points that are false here. And we're going to use that as a way to determine this kind of, again, this kind of like sphere of influence. Basically a range around the control point that will be affecting the grid. Okay, so again, slightly different technique, and it's interesting now to introduce this kind of true-false pattern, because we'll build on this in the next part of this week's exercises. Okay. Now I want to use this. Basically, I want to split. This data, the point data, into two different lists based on these true-false values. So I want the trues to be on one side and the falses to be on the other. So for that, we can use the dispatch. And I believe that's over in set and list, and you'll see it here in the middle, dispatch. All right, so we're going to put the points into L here, and we're going to take the output there, put it in there. And now I've got a list of things coming out of A and a list of things coming out of B. Let's take a look at what that looks like. All right, let's go ahead and just put some point parameters on this. And it may not give us a satisfying result just yet, so I'm going to turn this off, turn that off. Well, I suppose we can leave that on. Actually, let's turn it off, because I think what's going to happen is when I move this closer, I should be starting to see, well, let's see here. Oops, let's turn that on. Yeah, we're not quite at that stage yet, actually, so let's go ahead and turn this back on again. And this is really just going to affect our data here for now. Actually, we should be getting points out of there, so I just realized that there's a little mistake here. The point input actually is not the one from the closest points, but actually from the original grid here, the original kind of division of points. So yeah, so if we turn that off, actually, what I'll now start showing is that kind of range of influence there. So if I select this one, and these are the false values coming out, you can see that I could kind of make a change to the influence that these control points are going to have over this grid by changing the slider. All right, and if I select those, it's the opposite. So these are going to be the ones that the green ones here we'll use to actually draw the grid, and the red ones will be removed. We just have to find a way to draw the grid so that it appears as though there's a kind of a movement of a curve that doesn't break but continues around that area and then back up again. Okay. So what I'll do is actually I'll pause here, because I think that got a little shaky. So I'll just pause this out and just go ahead and do this. So you can pause your screen if you need to catch up for a second. Yeah, so let's start reconstructing that data set of points so that we can start to draw those curves. A couple things we'll need to do. First, we want to figure out which of these points is closest to those. All right, so let's go ahead and grab, once again, we'll go to vector and grab this closest points component here. And the B input, all right, is going to go into the points that we're searching from. And the A is, actually I grabbed the wrong component there. Make sure you're grabbing the proper component, which is actually closest point, not closest points again. Remember, it's not plural. So we'll go B there, and then and here. And actually, to do this properly, what we'll need to do, I think, is to flatten this out. Let's go ahead and flatten that, and that gives us the, you can see that we're now kind of finding a ring, just a single ring around that area that we saw before with this. We're basically just finding the ring around that in order to produce the next step, which will allow us to draw the curves in a way that it will make the curves appear as though they're sort of bending around that area. Okay. What we need to do is figure out what the indices of these are, so where they existed in the original list, which was over here. What numbers do they have assigned to them, basically, in order? Let's do that. So we can go over to set list and list index, or item index. The items are going to be the points here coming out of B, and the list that we need to refer back to is going to be, again, that original set of points there. Let me just extend that so you can see it. Now it's going to give us a bunch of values, the number values, where necessary. And now what we want to do is basically insert these points back into this list here using these indices to replace out the ones that were there before. So we're basically just reordering this whole list of points over here so that we can draw our curves in the way that will have an effect, in a way that these attractors will have an effect. All right, so we're going to go over to sets, list, and replace items. Okay, so let's do some replacements. Again, the list that we're operating on is that original set there. I'm just going to move these out of the way. We're using those as previews. The indices that we're going to need, coming from the component that we just used there, and the objects that we're actually going to replace them with is going to be here. Right? So if we take a look, we should have a similar or the same number of things. So we have 736 points here that we're going to use 736 indices in order to kind of make a swap from the points that again came from this set here. Just kind of move things around a little bit. Just for good measure, what I'm going to do is make sure there aren't any duplicates so that the next step of drawing the curves is nice and clean. So I'm just going to go over to vector, point, and call duplicates. Calling, again, essentially removing, and let that be. I'm going to go ahead and turn off a bunch of previews now, maybe at least here, and we can always refer back to those in just a moment. All right, and then we can start drawing our curves. And in order to do this, what I'll do first is pass it through a polyline component. So I'm going to go to curve, spline, polyline, draw out the polylines, which is going to look a little funky for a minute. Just going to turn that off. Then what I'm going to do is break those polylines down like we saw in the last example in a way to kind of smooth them out before I, if you will, kind of redistribute the points basically in order to redraw NURBS curves in a nice clean way. So we're going to go to divide curve there, kind of break these polylines down. And let's just leave it at a default, of 10 for now. We can always make changes later. And I'm just going to be turning off previews as I go here to kind of hopefully make this look nice in the next step here. So I'm going to grab spline and NURBS and use those points to draw them. And then we can go back and maybe turn those off because now they're a little bit in the way. Here we have a kind of developing result here. We can see that we can kind of change the overall area of influence. And each of those points is having an effect. If I go and move them around, of course you'll see an update, and they can kind of gang up or they could be separated. It has quite an effect on that because, again, we only really kind of found the exterior ring, really. So all these points are going to kind of converge at that area. So it has a different effect than the example we just saw, but one that I thought would be interesting to compare it to. And again, I find these curves to be needing a little bit of smoothing just to kind of even that out a little bit further. And this time I'll just use the rebuild for that. And I believe that's under curve. And over in the box here, the utilities box, we should be able to find rebuild. And I'll turn those previews off. And we can do a couple things here. We can change the degree a little bit, or we can, probably even better, we can just change the number of control points. So I guess I'll just do something like that. And I'll keep that up to something like 4 to see what that does. That's going to really smooth them out. Increase it a little bit more. and maybe 5 is kind of nice to demonstrate the difference there. You know, we turn that on, we'll see a huge difference. And I find the result to be a little bit more elegant, you know, but really it's up to what you're trying to do. As we can see here now, we're having more of an effect in a way, more of like a linear effect on the curve, almost as if it's made of maybe like wire or something. You know, the wires are sort of bending out, as opposed to before where they were really curving and kind of bending around, almost making circles. Now they're really more sinuous, they're more bendy-like, as opposed to, you know, like force flow, for example. Depending on what you're trying to represent, you can make changes to those curves. So anyway, just a little example, you know, again, from a pretty old and well-known definition from a good resource, and just kind of walking through it verbally with you, just to kind of build on what we explored in the last one.